Hello everyone, this is Afras Chauhan, and in today's video session, we will discuss about the different operators in a Scala. So, for example, the different types of operators we are going to use in a Scala, we will discuss these operators one by one. We will discuss arithmetic operator, relational operators, logical and bitwise, and assignment operator. Uh, I I think you should be able to understand all these operator by this program only. I have created a long program which is including all the operators. Okay, and I'm going to discuss their use one by one. So it would be enough for you to understand what is the meaning of any operator and where to use and why to use. Okay, and so without any further ado, let's start. So the first function is arithmetic operator, which we are calling from the main. As you can see, this is the first function we are calling from the main. And as you can see, the return type of this function is unit type. It means it, you are not required to return anything. Okay. So there is another way. If you have nothing to return, then you can use even this symbol also. So it says that you are simply going to calculate something and print something over the console. So instead of this colon unit equal to, you can use simple equal as we have seen. As you can see, it is over here. I have used the same way. Okay. So this would not return anything. Let's come to the operators. So it is plus, minus, multiply, divide, modulus, or the remainder. Okay, and yeah, that's it. I hope this the use of these operators were very clear. Nothing to you know uh, nothing to explain over here. I think these are very simple operators. This one would left you with the remainder. Let's say if you are using 50, you are taking the module of 50 by 30. It means it will left you with 20. Okay, so that's it. These are all arithmetic operators: plus, minus, cross, divide, modulus. Let's come to the relational operators. You have already seen the relational operators, but in languages like C, C++. Okay, one good thing about the operators is, irrespective to any language, if you are using C, C++, Java, Scala, or any other language, majority of the time, the meaning of these operators are same. The symbols we are going to use would always be the same. 99.9% I have seen the symbols are same. The essence of each operator is same in all the languages. Uh, I have whatever I have seen so far. Okay, uh, if you are using double equal operator in Java, C, C++, the essence of using this operator would be same. Okay, majority of the time, exception would be there. Okay, but what I have seen is the essence would always be same. Even the symbol we are going to use would also be same. So it is equal operator. Okay, and if you're using 50 and 30, it is actually checking they are equal or not. They are not equal. Okay, it would check greater than, it would check less than. Okay, this one would check greater than or equal to. I have also written over here. Okay, it would check less than or equal to. Okay, the good thing is all these uh, what to say uh, all these how can we express the result of all these operators, okay, would always be true or false. Okay, if a equal to b or not, either it can return true or false. So it would be same for all the operators. So the relational operators, if you apply relational operators over any operands, okay, you would expect to get true or false as a result. True or false as a result. Okay. So when you are using relational operator, this would be the scenario. I'll execute this program, but it would contain actually everything, every other operators as well. So I think let me uh, cover arithmetic, relational, and the logical operator. So logical operator, in logical operator, as you remember that we have and, we have or, we have this not operator. So the good thing about this operator is they would expect you to pass Boolean operands. Okay, C and D would always be Boolean, but nothing else, because they are logical operators. They would give you, you know, the same result as the Boolean operand would return, true or false, and they would also expect the same. They would expect true and false as a parameter. Okay, so the logical operator would always expect the parameter to be Boolean. This is the restriction with logical operators. So if C is true and D is also true, then this statement would return you true, and the negation of this would be false. So all these statements would return you either true or false. Okay, this or is if C is true and this is false, it can return you true. If this is false, this is true, this would also return you true. For rest of the for if C is true, D is true, then again it would return you true. In case of C is false and D is false, it would return you false. In case of and, you as you know, this has to be true, this has to be true. In this case, this expression would return you true. So these are three logical operators: not, or, and. Generally, with these symbol, you use logical operator or, logical operator and, logical operator not. You generally use this. So this symbol is actually saying you have to write something, some expression over here. Okay. Uh, as you know, we are going to discuss. Let me execute it with these first three operators. I'll discuss this bitwise and assignment operator later on. Let me execute it. So our program name is operators in Scala. So this is our program. Okay, so Scala C, and it would create a .class file of sample object. Okay, so sample object would be created as a executable file. So this is the result of arithmetic operators. This is the result of your I think logic relational operators. As you can see, they are either true or false. Okay, every expression is returning either true or false. Okay, you always remember that relational operators always return you true or false. Logical operators would also return you true or false, as you can see, but they would always expect you to pass true or false as an operand as well. In case of a relational operator, as you can see, we are not passing true or false. We are passing integer values. That's why we are saying it's a relational. We are trying to figure out the relation between values. Okay, logical operators, it's not actually trying to figure out the relation. It is trying to find out how they are logically formed together. That's why it is called a logical operator. We are going to use bitwise operator. Uh, Bitwise operator generally used with the single symbol. Okay, as you can see, we are using double AND here to represent logical AND. Okay, but to represent logical, bitwise AND, we have to use just one AND operator, AND symbol. Okay, so this is also called AND, and this is also called AND. But there is a big difference between logical and the bitwise AND. As you can see here, A and B are integers, but here C and D are Boolean. Okay, it means if you are using logical operators, you always expect to pass Boolean operands. But in case of bitwise operator, if it is in this case as it is bitwise AND, you can pass any value. Okay, I have also written over here. In case of a single AND or the bitwise AND, you can pass either short, integer, unsigned, integer, character, boolean, unsigned character, and long. Okay, so many thing data we can pass. But in case of this double AND operator or This is logical operator, logical AND. You only have to pass either true or false. This is the restriction. Uh, in case of double AND, 0 represents false and 1 represents true. But whereas in single AND, 0, if you pass 0, it would be considered as an int. If you are passing 1, it would be considered as a 1, because the bitwise operator would always convert this value into binary and then apply all the operations like and or, uh, you know um, and or, and we have this negation, okay, left shift, right shift. We have so many operations, XOR operations. It will be applied only on the bits of your number. So let's say if you're having 20, so it will be converted into the binary format. Okay, then bitwise, it means over each bit the operation will be performed. So I'll discuss this, okay, this uh, this AND function I'll discuss, okay, in detail, so don't worry. Let's discuss this. We can have AND bitwise, we can have OR as a bitwise, we can have XOR as a bitwise XOR. This is called bitwise XOR. We have ones complement in bitwise. This would also tackle the individual bit of your number. This is left shift, this is right shift, and this last one is little unique. This is what to say, this is right shift, but this is bitwise shift right. Actually, as you can see here, this is right shift. This is right shift, bitwise right shift. But this one is little unique. This is also right shift, but usually we write it like a bitwise shift right. So the difference we are going to discuss. Don't worry. Let's discuss first of all this A and B. So this is 20. So we are not actually trying to write 20. So let me write 1 2 3 4 5 6 7. So this is representing 1. This is binary representation, so this is 1. This would represent 2. Okay, and if we apply AND, okay, then the output would be, can you imagine what would be the output? The output would be this. And why this would be the output? Because this AND operation will be applied for each bit. So if you apply AND over 1 and 0, it would return 0. 0 and 1, it would return 0. Okay. And for rest of the bits, if you apply AND between these bits, it would always return 0. So even if you are adding 1 and 2, okay, if you are passing bitwise operator, it would return you 0. But in case of, let's say, 1, okay, in case of 1, it would return you 1. Okay, because AND operator, this AND bitwise operator would return you 1. Okay, uh, there is a one more important difference. Let's say if you are using this expression A and B, which can be integer, short, or anything. If let's say you're using boolean as well, you can pass boolean as well in this bitwise operator. So if this is false, okay, and this is true. If we apply both these operations, this is simple logical and this is bitwise AND. In this case, eh, both the operands will be evaluated. It means, let's say this is false, then the compiler would also check the value of B as well. But in case of logical AND, if this is false, the second expression will not be evaluated. This is the concept. So will not be evaluated the second operand if the first one is false. So these are the common differences between logical operators and bitwise operators. So I hope this is clear. This thing you can relate to. Let's say you have a number, and then the compiler would convert into binary format, and then the operators will be applied bitwise. Okay, bitwise. Let's say this is the bit. Okay, this is one bit, this is one bit. So we are applying this operator between these bits. That is why it is called bitwise operator. So you can apply AND, you can apply OR, you can apply this XOR. XOR means if you are just hold on, one and one XOR uh, one would be 0, 0 XOR 0 would be 0, 1 XOR, if anyone is true, if any variable, any operand is true, it would return you true. Okay, so if any operand is true, it would return you true. That is the concept. Okay, this is little different. So XOR is like that. One's complement is simple. If you are using this, okay, so it will flip the bits you are going to use. Okay, so this concept you have seen, I think you must have seen. So this the ones complement of this number would be 1 1 1 1 1, and at the end 0. Okay, this is left shift. Okay, so left shift, it is saying that whatever the value of a is, you shift it by three digits. Okay, so in binary you represent 3 like this, so it will push this string. Okay, this, okay, you have to push this string into this direction, into the left direction by 3. So as you can see, if you push this, you would have 3 zeros because you have to insert something over here. Okay, and this would this part will be pushed into the left, and left is nothing over here. Okay, we are assuming this is 8-bit long, but it would be 32-bit if it in case of the integer. So the first 3 bits, whatever they are, 0 or 1, they will be gone, and they will be shifted to the left direction. So if you are shifting this whole string by 3, it means you are erasing this and you are adding something over here. Then you would erase this, then you would add something over here, this one. If you erase this one, you are pushing this, and then you would add something over here. So the 3, if you are any decimal value, any integer value, you are shifting it by 3, you are pushing into the left side by 3 digits. Okay, 1 2 3, that's why we have added 3 zeros here. In the right shift, this is again the same. If this is the same, if this is the string, if we are pushing it to different direction, let me show you. So if this is 3, and we have, this time we have to push it into this direction, right, by 3. So these 3 digits will be 0 by default, and if you push these 3 digits, or erase it because these are the rightmost side digits, then the output would be 0 0 0 0. Okay, so now let's come to this uh, this uh, this bitwise shift right. There is a slight difference. There is a slight difference between this bitwise right shift and bitwise shift right. Only this difference, that this sign bit will always be preserved. In this case, you are not realizing this is 0, so I have taken it as a 0. This time this bit is 0. 0 means positive, that's why I have taken it as a 0. This will always be same whatever your number is. If it is 1, it will be 1. Rest of the digit will be shifted, except this first digit, because if you are using this bitwise right or bitwise left, they would preserve the sign bit. This would technically pass everything. It would shift everything. It doesn't matter it is signed or unsigned. So whenever you use this bitwise shift right, you always ensure that if you are using this, let's say 1, okay, if you are shifting it to right side by 3, okay, it means you are actually adding this to this string. Okay, this the string of bits. Here, this first bit is not considered as a signed bit, but in case of this, if there is a 1 over here, the output would also contain the 1. For rest of the bits you would apply, you leave the sign bit. But in case of bitwise shift right, you have to, uh, you are not required, or your sign bit will also be erased. So these are the differences between your, bitwise shift right and bitwise right shift. I'll execute this also to, let me clean it, clear it, let me compile it once again. Something. I think we have left with this. We can erase it. Okay. So as you can see, it is returning the final values. The bitwise, whatever the decimal value would be converted back into the decimal after, applying all these operations on the bits. First, the decimal value will be converted into binary, and then the operation will be applied on the binary format. And then whatever the result of that binary would be converted into the decimal once again. So this is the pattern. Let's come to the last assignment operator. These are very simple, very simple. If you are using C equal to A plus B, okay, assignment operators are like this. You don't need to have, this expression. Instead of that, you can use this. You are technically adding C into A. So why not use assignment operator, assignment plus operator, okay? This is actually addition and assignment operator, okay? Or this is called the subtraction and assignment operator. So instead of using this, you can use this. This goes same for the subtraction, for the multiplication, division, modulus. This is the left shift, okay? uh, Instead of writing C equal to C and C left shift by 3, you can directly write like this. This is the right shift. As you can see over here, we are actually assigning back it to some other variables. So we don't need to, okay? Uh, this is actually bitwise AND, what we have seen over here, bitwise AND, okay? So if this is also C, then you can use the assignment operator, okay? This is assignment XOR. This is assignment OR. Okay, so this is actually the combination of your bitwise operator and the equal operator. So these are very simple. What I'll do, I'll share this file. So first of all, let me execute this. Okay, I think I commented. Okay. Okay, as you can see, these are the result of your assignment operators as well. So what I'll do, I'll share this file over Moodle as well. Okay, and you can access this file. But for the task, I'm going to give you as a for the practice or for your practical or which you need to submit. Uh, you have to create a certain task. I'll give you. You are not supposed to copy this code directly. I'll share this code, but you are not supposed to copy this. I'll give you the different operations. One thing is very important that as you can see, I have created a different function for this bitwise operator, and I'm calling this from the main. This practice you have to do. Okay, you are not supposed to write much in the main code, because if I'm the coder, I should understand the flow. Okay, I'm calling arithmetic operator, something would be written inside the function. I'm calling relational, and so on. Okay, so this should give you the logical aspects of your program, and the whole code should be in the individual functions you are going to create. So this is how you are going to manage your code. Irrespective of Scala, you should practice this in any other language. Always write complex operations, task in one individual function, and then call it whenever it is required. So this is all for today. Okay. And if you have any doubt, you can comment down below to this video and I'll get back to you accordingly. So So thank you so much and have a good day.